have your attention, please? We have got just a couple things to do. Jacob's got a question. It was on. I thought it was. So what do you do if you couldn't find the homework?
Email you.
Try and go home? Email me, right?
Well, I mean, I was fine with it not being there.
Right, but, okay, so I'm going to address this to everybody. And I'm not trying to put you on the spot, but I am trying to make a point. Okay? I actually thought that I had it there, but I must have put the AP physics stuff up. So sometimes I miss these things, right? So here's the thing. If you're looking for the homework and you didn't get it written down yesterday or on Friday when I had it up on the board, because I know I had it up on the board, because I saw people taking pictures and writing it down. If for some reason you don't know what the homework is, there are a couple options, right? So I don't actually collect the homework. So, is it the end of the world if you don't get it done? No, but this is the day that I'm going to go over it in class, right? So if you have questions, now is the time to ask. If you don't know what the homework is, you can either just say, oops, I guess, whatever. Or you could send me an email. I was up until 11:30 last night, so I totally could have responded, said, here it is, and then you could have had it, and then you could have done it at 11:30, or, anytime before that. I got up at, 5 something, so, there was lots of opportunity. I totally would have helped you out. I didn't realize that I missed it. I apologize. My fault on that part, but you got to take responsibility for your learning as well. Fair? Yes, sweet. All right. That all said, questions that you have, so those are the answers. I, in a perfect world, would have an infinite amount of time and would be able to put all this stuff up online, and I apologize that I don't have time to do that. But there are the answers now to 1, 3, 2, and 4 from those 2 different pages. Are there any of those that you would like to go over today? Go, Miss Cara, what you got?
Okay, first I got a couple questions.
Yeah.
The first question is, for number 1, you put it in scientific notation, but do you have to?
You do not. No, I literally just copied it out of the book, and that's the way they had it written. So if you had, I'm gonna wake my computer up here. So if you had 2500 kilogram meters per second, totally fine.
Okay.
I'm okay with that. Yeah.
And my second question is, can you do one of the problems for page 203?
For sure. Which one would you prefer?
Can we do number 2?
Absolutely. Yep. So if you didn't know what the homework was, or you didn't get it done, or you just want to make sure you know how to do it, then this is the time that you can get your homework out, right? Or get a piece of paper out and write it down. Question. It's frozen, so you can't see all of the things that I did. Thanks for telling me that. Boop, there it is. 2,500 kilogram meters per second. Here we go. So thank you. Let's go. All right. So this is page 203. Question number, you said number 2. Is that correct?
Yes.
Okay. All right. So let's take a look. It says an 85 kilogram fisherman jumps from a dock into a 135 kilogram rowboat at rest on the west side of the dock. If the velocity of the fisherman is 4.3 meters per second to the west as he leaves the dock, what is the final velocity of the fisherman and the boat? Hi. Thank you. Thank you. All right. What's that?
I'll stop with Alec.
Oh, okay. All right. So, what are we going to do? I don't know. Let's write down some givens. Givens are always helpful. So, what do you know?
You know the mass emission, is that what it is?
Say that again.
The emission mass, is it?
The initial,
First mass.
the mass, yep, the mass of the, I'm going to write just the mass of the fisherman. Is that okay?
Yeah.
Mass of the fisherman is 85 kilograms. And we also know the mass of the boat, don't we? The mass of the boat was 135. So before I do any more, I'm going to draw myself a picture. So there's the boat. Here's the dock. Okay. So here's the fisher person. And there's their boat. Oh, that's going to be a really long jump. Let me not make it that long. Okay? So the person is going to jump into the boat. Does that make sense? Okay? Before they collide with the boat, before that person collides with the boat, what is their velocity?
4.30 millimeters per second.
4.30 meters per second?
Yeah.
Okay. So that's the velocity of the fisherman. This is a little bit confusing because of the F. I apologize. The initial velocity of the fisherman. What is the initial velocity of the boat before the collision happens? Zero. It's just sitting still, right? So the velocity of the boat at the beginning is 0 meters per second. All right. So this is kind of the before picture. The person is going to jump into the boat. Probably some of you have had an experience kind of like this before, right? Either jumping like from a dock onto a raft like in a pool, or maybe like stepping onto a skateboard or something like that. If you're like run, step on the skateboard. What's going to happen to the boat and the person? Where are they going to go? Well, this way, right? They're going to keep going, okay? How is the velocity of the person when he's in the boat going to compare to the velocity of the boat with the person in the boat? Once they've collided and they are together, their velocities are going to be the same. Does that make sense? So I have the same final velocity. So the final velocity of the fisherman is going to be equal to the final velocity of the boat